A detailed analysis projects that the mass production of humanoid robots starting in 2026 will trigger significant global economic transformations. Let's take a look at an exponential increase in robot production, leading to ultra low cost labor and a cascade of effects, including profound deflation, shifts in monetary policy, and a redefinition of economic growth. The economic impact unfolds in distinct phases marked by critical inflection points: 2026 to 2029 early adoption. With annual production under 1 million units, the initial impact is modest. Labor costs fall from 2.28 to $0.57 per hour, primarily benefiting niche sectors like manufacturing. This phase is characterized by mild disinflation, prompting central banks to gradually lower interest rates. 2030, the price drop. As production surpasses 1 million units, the average price per robot plummets to $10,000. This makes mass adoption viable across various sectors, triggering a deflationary shock of 1%. Central banks respond with aggressive rate cuts and expand the M2 money supply to stimulate demand. 2032, ultra cheap labor. The labor equivalent cost hits $0.20 per hour, undercutting global minimum wages. This leads to severe deflation, south of 4%, and a spike in unemployment. While real economic output booms, nominal GDP stagnates. Central banks are forced to bring interest rates near zero and significantly increase the money supply, though credit growth slows as deflation discourages borrowing. 2035, 2038, critical mass and systemic stress. With hundreds of millions of robots entering the workforce, hyperdeflation sets in, reaching 10% to 18%. This leads to negative interest rates, a collapse in credit, and widespread debt defaults. Real GDP grows dramatically, but falling prices cause nominal GDP to shrink, creating immense fiscal pressure. 2039 to 2040 systemic overhaul. As annual robot production exceeds 1 billion, the global robot population rivals the human labor force. The economy enters a deflationary boom where the massive supply of goods and services drives prices towards zero. Traditional monetary policies fail, prompting systemic reforms like debt jubilees and a focus on nominal GDP targeting. The chart shows the doubling of robot production annually, starting from 100,000 units in 2026 and surpassing 1.6 billion units by 2040. The unit price is projected to fall sharply, hitting a stable $10,000 after 2030. The labor equivalent cost per hour shows a steep decline, reaching $0.15 by 2040. GDP impact. While real GDP could multiply 10 to 50 times by 2050, nominal GDP may shrink as prices approach zero. This will necessitate a redefinition of GDP, possibly focusing on utility or well-being indices. Debt sustainability. Persistent deflation will amplify real debt burdens, leading to widespread defaults and banking crises. This could result in global debt jubilees or the adoption of new monetary systems. Policy shifts. Inflation targeting will become obsolete. Fiscal policy will likely shift towards universal basic income, UBI, funded by robot taxes and reduced work weeks. The transition could usher in a new era of abundance if managed correctly, but risks significant social unrest if the challenges of unemployment and inequality are not addressed.